All right, so what we typically do on Tuesday mornings is Ben comes prepared with a fun kind of topic for what we call the metabolic classroom. And today's topic is insulin alters metabolic rate. And the little description is, while a calorie is certainly a calorie, overlooking the effect of those calories on insulin means we miss a piece of the metabolic puzzle. So with that, I'll turn the time over to Ben.
Yeah, yeah. So my way of starting that description, mentioning this old idea that a calorie is a calorie, of course, strictly within the realm of physics, which is where that concept is born and where I think it should have stayed. A calorie is a calorie. If we're talking about this metric of measuring heat as a form of energy, then it is a calorie is a calorie. But when people invoke that concept and within a biological organism, things start to fall apart. Now, the old idea, of course, and everyone would know this, but for the one or two people who don't, the idea of a calorie in its origins as a metric or a unit of measuring heat, it is the amount of energy you would have to use to raise a given amount of water by 1 degree Celsius. And food can be burned. You can combust the food and you could see how much heat you'd get from that. And fat has more energy in it. It can give off more of this heat. It could be burned more than another macronutrient like glucose can. So the idea is, of course, the pervasive idea is that if you want to control your body fat, you need to simply be in a state of negative caloric balance. I'm not disagreeing with that idea in principle, but I would disagree with how people apply that idea of a calorie versus a calorie, because then it leads to the old tired idea and advice of eat less, exercise more, which just hasn't gotten us anywhere. Yeah, that's eat less, exercise more. I want to make sure I didn't flip those around. In the biological organism, if we overlook what hormones do to the body, then we are missing what I argue is a very relevant piece of the puzzle. And that's because insulin tells the body what to do with energy, especially it tells fat cells what to do with energy. But let me back up a little bit. Before I even mention insulin and challenge this idea of a calorie is a calorie, someone would look at a calorie from protein and they would say that has the exact same amount of energy in it that the body has to burn or store as an equal mass of carbohydrate. They have the same amount of calories per mass. And that's just silly because sure, if you take it and put it, light a little flame and you're holding this unit of protein or this unit of carbohydrate above that flame and you're seeing how it can combust and heat water in a flask above it. Yes, in that perfectly controlled fake little environment of physics, in a laboratory, then it would be the same. But when you look at what happens in the body, again, the idea falls apart. For example, protein is very expensive to digest. The body has to work harder to digest protein. So there's something called the thermic effect of food. When you eat something that's protein rich, you will have an increase in your metabolic rate. Your body is working harder to digest that. Now, all food, fat and glucose included, has a thermic effect. Just eating anything will stimulate your metabolic rate just because your body's a little busier digesting and then absorbing those nutrients and then doing something with them once they get into the blood. Protein does that much more than normal. So trying to apply the same caloric value to protein as you would say to glucose, I think is just silly. Moreover, you don't use protein for fuel. It should never be considered a fuel. I'm getting off on a protein tangent, but I'm just going to let it go for a minute more. Protein is only used as a fuel when the body is absolutely starving. When you've run out of fat tissue, that's when you have shifted from fasting to starvation. Now the body is using protein in order to create glucose. Even that costs some energetic value. So nevertheless, the idea that all the proteins you're eating are the same worth, that have the same caloric load and demand on the body, that you have to store it or burn it, because that's the way we look at calories. If what you don't burn, you're going to store. And if you're not storing it, that means you're burning it. Now I'll introduce another concept or another aspect to that in just a moment. So on its face, trying to equate all calories as if they're the same from the food we eat is just silly when you apply it to the human body. Now, mentioning insulin. This is a concept that I've been thinking a great deal about for years, and in fact was really the crux of the very first talk I gave at my very first low-carb meeting. It was reconciling this idea of what insulin is doing, not only by way of what it is telling fat cells to do, but then the whole body by extension. So if insulin is up, I don't know of an exception to this, and it would be difficult to really push this too far, but if insulin is elevated, the fat cell is storing fat. In a way, it doesn't matter what the calories are. If insulin is up, the fat cell is storing fat. Now, of course, if the body was very low calorie and you were artificially pushing insulin up, then the person would die from low ketones and low glucose, because those are the two fuels for the brain. So, it's a little hard to test that out. But even beyond the fat cell, insulin is so determined to store energy in the body because that's what it wants to do. It tells the cells what to do with energy. And the theme of that is to take in stuff from the blood and store it. And it can do that more efficiently. Insulin abhors wasting. It abhors inefficiencies. And part of this is reflected in insulin depressing the metabolic rate. Now, I've been debating on how much detail I want to go into with regards to mitochondrial coupling versus uncoupling. So for now, I'll just put that to the side. And if someone asks in the Q&A, then I can bring that up. But insulin slows metabolic rate. And in so doing, it actually helps the body be better at storing energy. So by slowing metabolic rate, then whatever the calories are that you're taking in, you're now storing them better than you were, as opposed to insulin being low. Now, with regards to some of the studies that I thought might be interesting to look at, the first one is, and there are links to all of these studies. The first one was published in the British Medical Journal in 2018 by David Ludwig, a friend and I would say a collaborator at Harvard. This was published in the British Medical Journal. What they found, they put people onto different diets that differed in the composition of glucose or carbohydrates and fat. And the group that consumed the meal that had the highest carbohydrate and lowest fat, they had a depression of their metabolic rate following that meal by about 100 calories if you extended that out to the day. So 100 calories throughout the day, that would have been the depression from eating the high carb, low fat meal. The group that ate the inverse, protein was the same for both. The group that ate the low carb, high fat, they had an acceleration of their metabolic rate by about 180 calories. So when you compared these two groups that differed completely in macronutrients with fats and glucose, or fats and carbohydrate, they had the overall difference between these groups was almost 300 calories. And the number of calories they were eating was exactly the same. Now, earlier I mentioned how the body, it's expensive to digest protein. It's not expensive to digest fat and carbohydrate. Those actual two fuels, the body can digest very easily, and the thermic effect of either of them is pretty similar. So fat doesn't have an advantage in that regard, as much as I'm an advocate of eating fat. However, the advantage to fat as a macronutrient is that fat alone has little or often, and some of the evidence is a little conflicting. If there is an effect on insulin, it's extremely modest, or other lines of evidence suggest there's no effect. So fat is insulin friendly in that it doesn't stimulate an insulin release. Glucose, of course, stimulates a significant insulin release. And I would strongly contend that the difference in metabolic rate that we saw in this study that gave people a meal to purposely press or alter the macronutrients, the difference we see in metabolic rate is likely a consequence of the changes in insulin, where the high carbohydrate group had a significant insulin spike, and insulin slows metabolic rate. Now, that study was done using a technique called doubly labeled water. The strength of that technique is that you can allow people to just live their life. You can measure the rate at which the cells are using this unique water molecule and then get an idea of the metabolism or the metabolic rate of the body's cells. So that was a strength of the study. They were free living people. Now, you would say, well, a consequence of a free living people is that you can't perfectly control every aspect of their environment. To me, that doesn't matter. One of the things I like about diets that let people just live their lives is that they're more real. Do you guys know what I'm saying? It's more than just you living in this little laboratory for 24 hours where literally every single aspect of what you're doing is perfectly controlled. Now, the next study did it that way. This was a study published in the American Journal of Clinical Nutrition by Kevin Hall's group. And Kevin Hall really has done some wonderful research, but I think it's safe to say he has a pretty strong bias against low carbohydrate diets. Maybe that's putting it mildly. So this study was done in a perfect metabolic like chamber where people were living basically in a kind of glorified cage where they could measure everything. It was perfectly controlled. And they gave them diets that differed not in calorie. It was exactly the same in calorie number. And this was a very short study because, of course, people are living in like a cage. But what they found was that the group that was adhering to the ketogenic or the lowest carbohydrate diet had a significant, it was slight, but it was still a significant increase in metabolic rate, in their energy expenditure. So one more line of evidence using both a different technique where it was a metabolic chamber versus doubly labeled water and slightly different protocols in the diet, it nevertheless once again found that metabolic rate was significantly increased on a diet that was adhering to a low carbohydrate diet or one that was keeping insulin low. And then the last line of evidence that I wanted to mention was a meta-analysis that compared all the available studies that had looked at energy expenditure in humans on low carbohydrate or high carbohydrate diets, of course, with fat going in the inverse. And what they found was very interesting, and it might shed some light onto some of the discussion that people have about this concept, where they found that the sum of all the data suggested that acutely within a 2-week period or so, people that shifted over to a low carbohydrate diet tended to have a lower metabolic rate. And then after 2 weeks, it went higher. It was above the other group. It was above the high carbohydrate group. Now that actually challenges some of the studies I just mentioned, but this meta-analysis looked at all of the available data, and that's what they found, that in that 2-week period of time, there was a reduction in metabolic rate, and then after that, it went above. So that's the data. I am strongly submitting that insulin is a relevant variable there. And you know what? I'll elaborate on the mitochondrial aspect now. We published a paper, 2 papers from my lab over the past 2 years, where we looked at what insulin versus what ketones were doing at the fat cells themselves. And very briefly, anyone who knows me, I'm sure through social media, has heard me talk about mitochondrial coupling or uncoupling. But the simplest way of looking at this is, of course, the mitochondria are the engine of the cell. That's what's taking in fuel and then burning it in a way. We say burning because you need oxygen to do that. So it is almost like you're stoking a little flame, but it's not actually burning like you'd think of a flame. But it's burning fat or ketones or lactate, all those oxidative fuels. And then when I mention the word coupling versus uncoupling, it's basically the spectrum of how perfectly the mitochondria are doing it. Mitochondria that are perfectly coupled, that means they are only burning the fats, for example, that they need to get a molecule called ATP. ATP is the name of the molecule that the cell is actually going to use to get work done. So if mitochondria are perfectly coupled, then they are only burning energy when they need it, when the cell needs it. And it's wasting very, very little. Well, if it were perfectly coupled, it'd be wasting none. Now, on the other end of the spectrum, we have mitochondria that are more uncoupled. And in this case, these mitochondria are very unique because now they're burning energy, not because they're burning fat, not because the cell needs energy, but because it can't help itself. It's burning it just to burn the energy. And so it's very inefficient, if that makes sense. It's just wasting energy that it's burning. Now, this inefficiency, like any chemical reaction, inefficiency manifests itself as heat. And so uncoupled mitochondria will generate more heat. Now, part of the taking this to what we did in my lab, we looked at what was happening in the fat cells, and we found that insulin pushed fat cells to be more coupled. In contrast, when insulin was low and ketones were elevated, the fat cells were more, their mitochondria were more uncoupled. So now we had mitochondria that were wasting energy. And in the rodent models that we were using, there was a detectable increase in metabolic rate. Now, what's funny about that little tangent there with mitochondria uncoupling, you'll hear advertisements and things on the radio. I'll never forget this one. I laughed out loud where it said basically, you need to fix your metabolism. You need to take this supplement and it'll help your metabolism work more efficiently. And I just thought, oh, you clowns, you want to be less efficient. If you really wanted to lose weight, you would want to be less efficient. And then this sort of, to bring this back to insulin, because that is where I started, insulin makes the mitochondria more efficient. It makes the cell more efficient. It only wants it to build things. It doesn't want to waste. And of course, that's essential. Thank heavens for insulin. We need it. We have to have it. So lest anyone think I'm vilifying it, we need it. When a cell is trying to build things, we want it to be very efficient. It's building something for a purpose. We don't want to make it start wasting energy. When insulin's low, what's so interesting about that state is that the body can't help but burn. When insulin is low, the body cannot help itself. The cells can't help themselves. They must be burning. They must be breaking down and using the energy, even to the point that the body is burning more fat than it needs. And this is most obviously manifested in the liver. When insulin is low, the body and the liver starts burning fat. It can't help it. If insulin is low, it can't help it. But if insulin stays low, it still can't help burning fat, but it's burning more fat than the cells need the energy from that fat burning. And now we start to produce ketones. Ketones really are like this exhaust valve, this pressure valve. When the liver can't stop burning fat, which it can't help but do when insulin is low, as I said, it's burning more fat than it needs. And now it starts producing ketones. Ketones literally are the product of when the liver cells just can't burn any more fat. It starts diverting. It is breaking those fat molecules apart. It can't help it. But rather than using that to produce ATP, this molecule that the cell would need to get stuff done, to get work done, it now sends it into this pathway of ketogenesis. Now, the interesting thing about ketones, of course, they have a caloric value in and of themselves, slightly lower than glucose. So ketones are an energy source for the body, including the heart, which we'll get to maybe. But ketones get excreted from the body. When someone is in ketosis, they are breathing out their ketones and they are urinating out ketones. Well, remember, every little ketone is a piece of fat. And so it's like this person is breathing out or urinating out actual pieces, little pieces, mind you, fragments of burned fat. Now, that's relevant because earlier I'd mentioned that the body, when we try to induce this calorie as a calorie paradigm, or invoke it rather, we say that the energy has to be burned or it has to be stored. Well, when it comes to ketones, we have this third avenue where the energy is just wasted. We are just dumping this molecule, which has a real, actual caloric value, this piece of fat, if you will, a little burned piece of fat. We're dumping it right back into the atmosphere, into the universe. So it's a way of kind of ejecting this energy, which the body does when insulin is low. But that isn't accounted for. We account for body heat, which we measure as metabolic rate. But when we are breathing out ketones and urinating out ketones, that represents actual calories that no one is accounting for when they're trying to invoke this perfect caloric balance. But all of it comes back to insulin. Insulin tells the body what to do with energy. If insulin is up, then the body will have a lower metabolic rate, and insulin's wanting the cells to store energy and build things. If insulin is low, then the body will have a higher metabolic rate, and it will tell cells to break things down. Now, you need both of these cycles. You need to build and break. And to build well, even like building something like muscle and bone, you have to have periods of breaking. And you know what, I hope everyone knows what I mean by that. That's maybe a topic for another time to talk about autophagy. But health, a good, healthy body, you want to be building and breaking. And when it comes to the fat cells, you want to have states of low insulin so that these fat cells can be breaking down their triglycerides more often than they're building them back up.
That's awesome, Ben.
Fantastic.
Yeah.
You know, Ben, that we often have our coached clients who are new to this space. They're just getting started with low-carb eating and trying to reverse their insulin resistance. And they notice that their breath and their urine have a very distinct, almost, I don't know how to even describe it, but you just said why, right?
Yep. Yeah, so the ketones, well, now the ketone that they're breathing and urinating out is a ketone called acetone, but that matters. So very briefly with ketone biochemistry, when you are breaking down those fat molecules, the first ketone you'll make is acetoacetate, and then acetoacetate has two avenues to it. It will turn into beta hydroxybutyrate, which is the main circulating ketone, which is used as an energy when beta hydroxybutyrate is pulled into a cell. It actually turns back into acetoacetate or acetoacetyl-CoA, and then it splits and then goes into what's called the citrate cycle or the Krebs cycle, or some people will very erroneously say the citric acid cycle. But nevertheless, that's how that works. Or the acetoacetate will get, rather than BHB, it'll get converted into acetone. And once it's converted to acetone, it's irreversible. That is a molecule that is destined to leave the body. It'll get filtered out through the urine or breathed out at the level of the lungs. Yes, so that's exactly the molecule that gives either of these their unique smell.
Mm-hmm. Carly, Rich, any specific questions about the topic?
Yeah, I have one question. I often see people who get hot as they start eating this way, noticeably different body temperature, and sometimes people who get cold. What do you make of the temperature changes in both directions?
Yeah, so I can only speculate, of course. I think that there is something to be said for the body temperature that you notice when you're eating low carb, like something protein rich like meat. I've heard people talk about meat sweats. Have you guys ever heard that term before? Mm-hmm. Where you're eating and you're just getting hot. That's very likely just the thermic effect of whatever that food is, and meat does that very, very well. So I would say if someone notices this heat and it's when they're eating, I would think that heat would be noticed more in the midst and shortly following meal times. And then in contrast to feeling colder, it could be a result of people losing weight, but I don't know. Carly, you'd have a better feel for when they're noticing this, and I wouldn't know anything beyond that speculation.
Okay, that's great. I actually had a client this morning who corrected us about the Redmond salt. There is a little trace of iodine in that, very small amount, and she also told me that she started iodine and noticed her feet got warmer. So maybe that could play into it too. Your level of iodine affects how well you circulate.
Yeah, I would think, I wonder whether it would be because maybe she was a little iodine deficient and wasn't able to make the normal level of thyroid hormone.
Yeah.
Iodine probably has non-thyroid related effects. I'm sure it does. I don't know of them, but so I'll lean into what I do know. I wonder whether her iodine consumption allowed her to create a higher level of thyroid that her body needed, and that would stimulate blood flow and body temperature, which it would.
Yeah, she was hypothyroid, so that makes sense.
Okay, yeah, good, yeah.
Great.
Anyways.
Any other items related to the classroom topic today?
Well, Jack, I'm glad Bay went through the calorie in, calorie out, and the coupling. Those things are really important for our clients to understand because they've heard this calorie in, calorie out theory their whole life since they were children in health class. Yeah. And so for them to really get a foundation of what that really means and the effects of eating a high-fat, low-carb is really important.
Yeah.
Well, I insist no dietary strategy should start with or maybe even ever get to actual calorie counting. Not to say that a person wouldn't deliberately eat less in certain instances, but to take it to the point of counting the calories, that to me, I suppose it could work, but it does, even when it works, it's built on what I think maybe best be described as a myth. This idea that you can perfectly account for what every calorie is doing that you're eating, how you're digesting it, how you're absorbing it, what it's doing to actual energy expenditure in the body, and then what your actual energy expenditure is and where those calories are actually going. There's so much nuance that you couldn't possibly get. So to me, calorie counting is just built on a false idea when it's applied to humans, and leads mostly to grief.
Yeah, yeah.
Well, Ben, I don't want to give you too big of a head, but I remember at Breckenridge when you gave your first talk, I was sitting next to some guy and he just looked at me and said, "Who in the hell is that guy?" Because you were talking about this coupling stuff, and it was awesome. That's just, I know him.
Well,
He's my
I
buddy.
was thrilled. You know, yeah. Oh, yeah. And in fact, you said, "Don't be impressed. He's actually a big weenie," which is totally true. Yeah. So I do think that the uncoupling coupling idea is very relevant. It absolutely is something that happens. And I think it just is a warning to people. My hope is that it would have been, although it doesn't tend to be, but it would warn people against trying to engage in this fruitless effort of counting or accounting for calories.
The only time that we ever talk about calories in coaching is, I think there's a lot of paradigm shifting. We talk about this a lot that has to happen to adapt to all this new education that you're bringing about. And I think one of the struggles we have is that when we're used to eating high carbohydrate diet, our plates are big and we eat a lot of food. And it is really hard for people to recognize that if your plate, let's say you go from a regular dinner size plate to a small salad plate, you're actually getting the same amount of energy in a little plate if it's full of protein and fat. And so, we might have somebody who's struggling and not grasping these concepts. We'll have them track for just 2 or 3 days so that they can see with their eyes, what it looks like to eat a regular portion, because we're so used to incorrect portion sizes that we can't grasp the concept without actually counting and seeing calorically what we're getting.
And Carly, we've never been taught to be intuitive. I never learned that in college, ever.
Yeah.
It was never about, stop eating when you're intuitively full. It was a caloric issue.
Yeah.
Get on your fitness pal and start tracking your calories, and when you've had enough calories, then stop eating, which is just silliness.
And speaking of full, I was participating in a conference not too long ago, and the person speaking before me was speaking about food addictions, and the obvious topic was her describing sugar addiction and defending that it is a real addiction. But she mentioned something that I will never forget, in part because I would struggle with this. It was addicted to feeling full. And they feel like they have to eat themselves. They have to eat enough to the point that they're uncomfortable. And feeling, if they don't feel full, it is uncomfortable for them. In contrast, I mean, they're addicted to feeling uncomfortable because they're stuffed. And the idea of being empty in their stomach is so abhorrent and so deeply uncomfortable to the person that they never can do that. Someone will say, "Well, I can't fast. It makes me sick. I feel nauseous." No, you're just addicted to having your guts stuffed with food at any moment. And of course, when you go low carb, you have to learn to get around that, because if you're eating something that is so calorically dense, Carly, to your point about there is value in at least acknowledging calories and density, then if you're eating enough meat and butter and whatever to feel stuffed, well, that's going to be a hell of a lot of calories that your body's going to have to reconcile and deal with. So anyway, with food addictions, that's a topic for another time, but there's nuance that is often overlooked.
Yeah, I've heard you, Ben, use the term, I think it was you, it might have been Dr. Berry, if you can get the mindset to where you eat until you are not hungry, rather than eating till you're full. It's a subtle difference, but it's a difference that makes a lot of difference if you start thinking that way and being more intuitive about it.
Yep. No, and I think that applies even more so in the case of fasting, where someone would be shocked if they're a little hungry maybe at the end of their fast. They'd be surprised at how little they actually need to not be hungry in the wake of that fast.
Yep.
Well, great. Well, great topic. Thank you, Dr. Bikman, for bringing that to our classroom today. And